This is me and my partner Yash's homework video for question 6.9. Our questions, part A, we had to prove that dP over dt with constant s is equal to Cp over T times V times alpha P. And for part B, we had for an ideal gas along an adiabat, P over P initial equals T over T initial to the power of Cp over R. Demonstrate this equation is consistent with the expression from part A.
So starting off with dP over dt with constant s is equal to Cp over Tv times alpha p. We know that alpha p is equal to 1 over v times dV over dt with constant p. Substituting that in, we can cancel out the v terms in the denominator, leaving us with Cp over T times dV over dt with constant p.
We can rearrange this by multiplying the inverse of dt over dv with constant p on both sides, leaving us with dp over dt with constant s times dv over dt with constant p is equal to cp over t. And we know that cp over t is equal to ds over dt with constant p. So we can substitute that in, giving us dp over dt with constant s times dv over dt with constant p is equal to ds over dt with constant p.
We also know that ds over dp with constant t is equal to negative dv over dt with constant p. This is due to a Maxwell relationship saying that the second derivative of an equation with the respect to the opposite variable are equal to each other. So plugging that in, we can get negative ds over dp with constant t times dp over dt with constant s is equal to ds over dt with constant p. This is the same as the chain rule, saying that we have three variables and rotating those around, we can get those equal to negative 1. So rearranging this is actually the same as that chain rule. So we can say that the initial equation is in fact true.
For part B, we had that P over P initial equals T over T initial to the power of Cp over R. Bringing P initial to the other side, we get P equals P initial times T over T initial to the power of Cp over R. And we can just rearrange this equation, giving us P equals P initial over T initial to the power of Cp over R times T to the power of Cp over R. We're going to treat that boxed area as a constant because there's no variables.
So we want to take the derivative of that equation and with respect to t and holding s constant. With that, we get pi over ti to the power of Cp over R times Cp over R times t to the power of Cp over R minus 1. Rearranging this equation, we can get Cp times pi divided by ti to the power of Cp over R, all that times R, multiplied by t to the power of Cp over R minus 1. We can also note that Cp over R minus 1, we can derive Cv over R from that, resulting in pi times Cp divided by ti to the power of Cp over R times R, multiplied by t to the power of Cv over R.
So now we're going to simplify some of our work. So we have P over Pi equals T over Ti to the power of Cp over R. We can distribute the exponent to both the T and T initial, and then we are going to bring the T to the power of Cp over R to the left side and the P initial to the right side. This helps us eliminate the constants Pi and Ti, and this will give us dP over dt with constant s equals P times Cp times T to the power of Cv over R over T to the power of Cp over R times R.
And we simplify once more by taking Cv over R to the denominator, which gives us P times Cp divided by T to the power of Cp over R minus Cv over R times R. We can simplify that by taking Cp over Cv, Cp minus Cv equals 1, taking the R value of both, Cp over R minus Cv over R equals 1 over R. So we can simplify that to 1 over 1, essentially. So we are left with P times Cp over RT.
So now we're going to compare this with our answer in part A. So in part A, we had dp over dt with constant s equaled cp over tv alpha p. And we know that v equals rt over p. So if we derive this with respect to t, we're going to get dv over dt with constant p equals r over p. We also had in part A that alpha p equals 1 over v times dv over dt with constant p. So we can plug those values in to get dp over dt with constant s equals cp over t times v times 1 over v times dv over dt with constant p. We'll cancel those v terms out and plug in the r over p. This leaves us with dp over dp over dt with constant s equals cp over t times r over p, which simplifies, if you bring the p to the top, to cp times p over rt, which is the same answer we had in part B. Thank you guys for watching.